After we talk about Pluto, we finish talking about the solar system by talking about comets. There's a reason for that, and it has to do with where comets tend to come from, out beyond where Pluto is. We would all love to see a big comet like this in the nighttime sky. It doesn't happen often enough. When they start to get a little bit closer than the orbit of Mars and start to get close to the orbit of Earth, the sun starts to heat them up and starts to heat up the gases in them and pushes those gases out to make a great big long bright tail, which we would love to see filling up the sky for the really spectacular comets that we've heard about from the past. Now, if you look carefully at pictures of comets, you should notice that most comets have two tails. One is a gas tail, so when the gases are evaporated off of the comet body, called the nucleus, then those gases are pushed by the solar wind of the sun straight back away from the sun. But the other part of that tail, the second tail, is the dust tail, which is larger particles. The sun doesn't push them around as easily, and so they tend to fall behind the comet also, but have a little bit more of a curve to them, like they're following the orbit of the comet as it goes around the sun. I'm going to call comets dirty snowballs, and that's not to be mean. That is a term that actually is considered to be a pretty good description of what a comet is. When I say comet now, I'm talking about the center portion of it, the nucleus of it, the part that's always there even if it doesn't have a tail because it's further out in the solar system. The nucleus of a comet is not necessarily that big an object, only about 1 to 10 kilometers in diameter. That's extremely small considering that the tail of a comet can be all the way up to 1 astronomical unit long. Now, when we look at these nuclei for comets, we see that they have lots of dust in them. Dust is little particles of rock and specks of other kinds of elements. And then we also talk about the ice that makes up the dirty snowball. The dust is the dirty part, and the snowball part is frozen water, frozen carbon dioxide, which you sometimes might call dry ice, and even frozen carbon monoxide. When the last time that Halley's Comet came in to visit us, the Europeans sent out a space probe called Giotto and got in close past all of the gas and dust that was coming out of the nucleus and got us a close-up view of what the nucleus looks like when the sun is heating it up and making that material come shooting out of the comet and making a nice big long tail for us to look at. Now, when we are talking about comets at the end of the solar system, it's because we're talking about where they come from. Comets that we've seen orbiting, which has orbits that bring them in to visit us, let's say 200 years or less. When those comets with periods of 200 years or less come in to visit us and we track their orbits to see where they're hanging out when they're not coming in close, they tend to be hanging out in a flat area within the plane of our solar system, and this flat area begins right where Neptune's orbit starts and moves out from there to about 1,000 astronomical units. So this is another broad, flat belt area like an asteroid belt, only these objects aren't like asteroids. They have lots of iciness to them, so we call this the Kuiper belt, named after its discoverer. So the Kuiper belt is the edge of the solar system in the plane of the solar system, but that's only describing the comets that come and visit us often, 200 years or less. There are comets that take much longer to go around in their orbits. And for comets that take much longer to come in and visit us, we've noticed when we trace back their orbits that they don't just come in the flat part of the solar system, they come from all around the solar system, like we're inside of a great big spherical shell of comets that are hanging out there just waiting for some little disturbance from maybe another neighboring comet or something to swing them out of their orbit so they will come in and visit us and give us a great big show and then go back out and not be seen for many hundreds, maybe even thousands of years again. when we calculate where those comets must be hanging out, they are as far away as 40,000 astronomical units, maybe all the way up to 100,000 astronomical units. So since this is all the way around us, it's not a belt. We're going to call it the Oort cloud, after the person who figured out it must be there. So when we talk about what's the last thing in the solar system, it's not Pluto. It's not even Pluto's friends in the Kuiper belt. The edge of our solar system we would consider to be the Oort cloud.